6.4, vectors and dot products. Dot products are the way that we multiply one vector times another vector. And I'm going to leave this blank up here for a second. So it's the way that we multiply a vector times another vector. How do we do something like u dot v? Like, what is the process of what it looks like? What I'm going to tell you is if you took the vector 3, 6 dot 4, -2, your answer would be 0. I want you to see if you can kind of reverse engineer this thing. What happened to multiply these two vectors by each other? And I hesitate to call it multiplying. It's really dot. There's another way to multiply called a cross product. And I don't want to, we're not going to be getting into that, but it's really dot product. So if you did the dot product on these, you'd get 0. And then I'll also tell you if you did the dot product on these, you'd get -3. So think about that for a second. Look at those two examples. Can you find out like what was done, like what method was used to get those two answers? I'm going to have you turn to your friend and share your idea. How do you think the dot product was used to get those two answers? Go for it.
8 times 0 is 0. Like 3 times 4 would be 12, and then it'd be minus 6 -2.
The 0 is going to be 0. And then 1 plus a -3, which is 0 minus 3. And that'll give you. Oh, okay. So yeah, it works for the same. Because it'll be positive.
How long are we doing those for today?
Okay, so if vector u is x1, y1, and if vector v is x2, y2, then what would you do with these if you did u dot v? Can you explain some of your explaining in words just a moment ago? Like, what would you do with these to get its dot product?
How you get it? How you multiply them? So you just multiply the x and the x, and then the y and the y, and then add them. So
take the x times the x, multiply the y times the y, and then add them together. So it wasn't obvious from the beginning, but hopefully after you saw a couple of examples with answers, you're able to, again, work backwards to get the idea that this is how you would do the dot product. The dot product is the way that we multiply one vector times another. Let's do a little bit more with this vector arithmetic, then we'll look into some of the applications of what this dot product will do for us. I have 3 vectors, u, v, and w. Doing order of operations, can you do this vector arithmetic? There's u dot v, w, u parentheses v plus w, and then magnitude of v. How does that apply to the dot product? So let me give you a chance to try to see what you can do with these. First one, do the dot product first because it's inside of parentheses. The dot product was -10. Distribute that to both the 6 and the 5 from vector w. We get -60, 50. The second one, you're going to do v plus w first. So we're adding them. So v plus w is 2, 6. Add the like parts, add the x's and x's, add the y's with the y's. And then you're doing vector u dot this one. So we have 3, 2 dot 2, 6. 3 times 2 is 6. 2 times 6 is 12. Add those together, 18. The last one is the magnitude of v. So maybe you recognize this notation from before. It's like the double absolute value bars is the magnitude of this vector. It's the length of the vector. And we had a formula for that. It was the square root of x squared plus y squared. It was like the distance formula. But think about that. If you did x squared, isn't that x times x? And if you did y squared, isn't that just y times y? And then we're adding them together. So what is this? This is essentially the dot product. X times x plus y times y. That's the way it was described to us just a second ago. So when we are doing the magnitude of v, it's essentially the square root of v dot v, the dot product. Some of you were getting really quick on doing those dot products. When I do v dot v, it's -4 times -4 plus 1 times 1. Add those together. So the magnitude of v is equal to 17. It's a variation on the distance formula. There's another way you can do the distance formula. Just do the dot product on it. So that's one of the reasons why we're looking at the dot product. One, because it's just kind of playing around with the vectors, doing some arithmetic with it. Here's our first little application of that. The bigger one, and probably the main point of bringing up this dot product, is to solve problems like this. What will the dot product really do for us? Well, it'll help us to calculate the angle in between two vectors. So on a graph, I could use the distance formula to find the length between two segments. But if I have two lines or rays or segments, or as we're going to use them as vectors, can I find a quick way to find the angle between them? And there's multiple ways to do it. I can make it into a triangle, use law of cosines, but this formula is going to be a little bit shorter for us. So how do you find the cosine, or how do you find the angle? The formula is the cosine of theta. The cosine of that angle between the two vectors is u dot v. So find the dot product divided by the magnitude of u times the magnitude of v. I'm not going to derive this. It's a variation on the law of cosines. But this is a way we can find the angle in between two vectors. Let's go through an example of this. What does this mean? How do we actually use it? So I have two vectors here, vector u and vector v. Vector u is 2, 5. How do I know it's a vector and not a point? It's because it has the pointy little brackets and not just the parentheses. Okay, so that's how we know it's a vector. What vector u does is from wherever it's starting, it goes right 2 and up 5. Now, we could start wherever we wanted to, but the most obvious place to start, the easiest place to start, would be to start from the origin. So vector u would go from the beginning point, from the origin in this case, right to up 5. There's vector u. Then we also have vector v, which is 6, 3. We're going to start at the exact same spot. From here, go right 6, go up 3. There's vector v. The goal is to find the angle in between these two vectors. I want to find that angle that I just marked off right here. Now, there's another way I could do it besides using this formula. Like I could draw in this right triangle, find this entire big angle right here. I could draw in this right triangle, find the smaller angle at the bottom, and then subtract the big one minus the small one, and I could get to that angle, and it would be okay. But this formula, I think, is just a little bit quicker. So I'm going to call this angle theta. Again, this is the angle between those two vectors. The cosine of theta, let's go into the formula, is equal to u dot v. Let's give you a chance to try this. Turn to your friend, share your answer. What is going to be the result of u dot v? So checking your arithmetic skills a little bit. 2 times 6 is 12. 5 times 3 is 15. Add those together, we get 27. And then it's over the magnitude of u. So square root. The magnitude of u is the square root of the dot product, u dot u. So u times u, so x times x plus y times y. 4 plus 29, or plus 25 is 29. There's the magnitude of u. Times the magnitude of v. So square root of v dot v. 6 times 6 is 36. 3 times 3 is 9. Add those together, we get 45. Now we have all the numbers we need, so go to the calculator. Alpha y equals n over d. I want to give myself a nice looking fraction here. I'm supposed to do 27 divided by the square root of 29 times the square root of 45. So we get this decimal. This is not the angle itself. This is what the cosine is equal to. So to finish off this problem, we're going to have to take the cosine inverse of that answer. And we get that the angle between those two vectors is 41.634 degrees. Again, we have the first vector, the second vector, the angle between them is going to be this about 41 degree angle. I want you to try the next one. Can you find the angle between those two vectors? The numerator is v dot w, 8 times 3 plus negative 6 times 4. 24 minus 24 is 0. 0 divided by all this. Now, there's no way that the denominator is ever going to end up 0 because that means that the vectors have no length. So we're always going to get something down here. But the interesting thing is that its numerator is 0. 0 divided by anything is 0. So what angle has a cosine equal to 0? So what is the angle between these two vectors? 90 degrees. So yellow formula, the cosine of theta is u dot v over the magnitude of u times the magnitude of v. Sticking with this idea for just a second longer, if this numerator ever comes out to 0, what's the angle always going to be? 90 degrees. Skip this example, go down to here. We talk about the word perpendicular. Perpendicular lines, perpendicular segments, perpendicular rays. A synonym for that when you're talking about vectors is the word orthogonal. So when you see the word orthogonal, it means perpendicular. You see the prefix ortho in various places. Normally it refers to something being like straight, right angles, something along those lines. And so if we have two vectors that are orthogonal, it means they're perpendicular to each other. We know that's going to be true if, it says if and only if this is true, they're orthogonal. If the vectors are orthogonal, this is true. What do we just find? Well, if u dot v equals 0, if their dot product is equal to 0, so the vectors might not be u and v, they could be something else, but if their dot product equals 0, that means those vectors have to be orthogonal to each other. Again, what is orthogonal? It means perpendicular, 90 degree angle. So in this one, we have vectors u and v. Now they are in the linear form. If I wanted to graph those, 3i minus 2j, so right 3 down 2, there's vector u. Vector v, negative 6 plus 4. Might look something kind of like that. So right now, does it look like these two vectors are orthogonal to each other? Assuming I drew it correctly, probably not. But we're just going to do a quick dot product to verify. U dot v 3 times -6, -2 times 4. Add them together, we get -26. So are these vectors orthogonal to each other? No. And at that point, I don't care. I'm not trying to find the angle between them. I just want to know if it was a 90-degree angle. It's not, so my answer is no. Go ahead and try the second one. So answer to this one is yes, dot product was 0. So these two vectors are orthogonal. They intersect at a 90-degree angle. All right, so one last type of problem. This is definitely getting into the realm of physics. How much force is needed to keep a 2-ton truck from rolling down a ramp that has a 20-degree incline? So word problem, we're going to make it into a drawing, and then we're going to see if we can answer this question using some trig. Now, it sounds like this might be an abstract question, but actually the calculations for this are going to be pretty simple. So we have a 2-ton truck that is on a ramp. The ramp has a 20-degree incline. So I'm just drawing just like the surface, like the flat surface right now. Here is my 20-degree incline. The bottom is just the horizon. It's a horizontal line. This line on the right is vertical. It's going straight up and down. That's going to be perpendicular because due to gravity, the weight of this 2-ton truck is going straight towards the ground. But when it is on an inclined plane like this, that weight gets distributed a little bit. I'm just going to say the truck is right here. Worst drawing a truck that you'll ever see. There's my truck. And there's a few forces that are going on in this one. There is the force it's exerting directly on this ramp, like that's pushing into the ramp. So I'm going perpendicular to that one. So this is going to be a right angle right here. So there is that, like the ramp has to have some force. Otherwise, it's just going to break. If it's not strong enough, if it doesn't have the force to keep the truck from breaking through, then it's not going to be in equilibrium. It's not going to be stationary. You also have the force that the truck is like trying to roll down this plane. Like when the truck is here, assuming there's no friction, it's wanting to roll down that plane. So there's a force there as well. And together, the force that's being exerted going down the plane of the ramp, as well as into the board, is going to be equal to this blue one. Now, this blue one is the one number that we have. This blue one represents the fact that this truck weighs 2 tons. And the way that gravity works, this 2 tons is the force is being exerted directly towards the earth. So there's my 2 tons. Together, the green plus the red equal the 10. The forces do. That doesn't mean that the length of green plus the length of red is 2. And if you look at this drawing here, I'll highlight it in yellow. We have a right triangle. So the relationship between the magnitude of the green, the magnitude of the red, and this hypotenuse would be through the Pythagorean Theorem. In this triangle, I know that this length is 2 because we were given that the truck weighs 2 tons. What is the measurement of this angle up here at the top? Think about the whole triangle, the original triangle. How big does this angle have to be? Got to be 70, right? So this angle is 70 degrees. The question is asking how much force is needed to keep the truck from rolling down the ramp. So of these two, the green is the force that the truck is like trying to roll down the ramp with. The red is the force that it's exerting on this ramp. So we want to find this value x. Whatever that force, like however much force the truck is like trying to roll down the ramp with, is the force we need to use to keep it from rolling there. Now think like if this is only like a 20-degree ramp and I'm trying to hold that truck from rolling down, I wouldn't have to use up as much force if compared to, assume this is like an 80-degree ramp. We have the truck right here. Aren't you going to have to be a lot stronger to keep the truck from rolling down in the second scenario? Whereas in the first one, because of the incline, it's not going to be quite as difficult to do. Erase. So looking at that yellow triangle, it's a right triangle, SOHCAHTOA. I can draw it over again. 70 degrees, 2 tons, x. What trig function is going to tie those things together? Cosine. The cosine of our 70 degrees is equal to adjacent over hypotenuse. Multiply both sides by 2. And we have the force of x. So take 2 times the cosine of 70. We generally don't think in terms of tons. We generally think in terms of pounds. So if you multiply this by 2,000, you'd figure out like how many pounds of force you'd have to use to keep this truck from rolling down the hill. So that's just, again, assuming it's in neutral, assuming there's no friction, that's how much force you'd have to exert to keep this 2-ton truck from rolling down this ramp. And depending on this angle right here, again, if the angle were smaller, let's say that this angle was only something like 2 degrees, and you have that same truck right there, I don't have to use nearly as much strength to keep that truck from rolling down the ramp because it's not as steep of an angle.